Have you ever pondered about the nature of the universe and how the smallest particles behave? This question might seem complex, yet it's at the heart of our understanding of the cosmos. In this realm of the infinitesimally small, we find quantum physics, a field as intriguing as it is mysterious. Here, particles can exist in multiple places at once, and single atoms can even morph into quantum waves. Well, today we delve into the fascinating world of quantum physics, more specifically, how single atoms morph into quantum waves. Atoms, the building blocks of all matter, behave in ways that challenge our understanding of the physical world. These tiny particles, so minuscule that millions of them could fit on the head of a pin, are not as straightforward as they may seem. They are the foundation of everything we see and touch, yet their behavior is anything but ordinary. To understand this, we need to delve into the concept of wave-particle duality. This is a fundamental principle of quantum mechanics, which tells us that every particle also acts as a wave. It's like saying that an atom can be in two places at once, or that it can exist in multiple states simultaneously. Sounds strange, right? Let's break it down. When we say a particle, like an atom, exhibits wave-like behavior, we mean that it doesn't have a definite position until it's observed. It's not just here or there, but everywhere at once, spread out like a wave. This is not because it's moving rapidly from place to place, but because it exists in a state of superposition, a blend of all possible states. But when we observe the atom, it suddenly appears in one specific location. It's as if the act of observation forces the atom to make a choice, to be in one place or another. This is the particle-like behavior of the atom. Now you might wonder how a single atom can be both a particle and a wave. Quite frankly, nobody knows for sure. It's one of the great mysteries of quantum mechanics. Some scientists believe that it's not the atom but our knowledge about it that changes. Others suggest it's the universe itself that splits into multiple realities, each representing a different outcome. What's clear, though, is that atoms aren't just simple particles. They are, in a sense, shapeshifters, morphing between being particles and waves, depending on how we look at them. So atoms, with their dual nature, lead us into the realm of quantum physics, where the usual rules of the universe don't seem to apply. Now imagine these single atoms, not as tiny particles, but as waves of possibilities. Welcome to the world of quantum physics, where the norm is defied and the extraordinary is routine. Quantum physics gives us a peek into the strange and fascinating world of the very small. It reveals that single atoms don't merely exist as tiny particles, but also as waves. But what does this mean? Well, let's delve into the intriguing concept of quantum superposition to understand this better. Quantum superposition is a fundamental principle that allows particles to exist in multiple states at once. It's a bit like being in two places at the same time. In the quantum world, an atom doesn't just exist in one place or one state. Instead, it can exist in many places and states simultaneously. This is what gives rise to the concept of quantum waves. Quantum waves, or wave functions, represent the different states an atom could be in at any given moment. It's a little like a cloud of possibilities. This cloud isn't just around the atom, it is the atom. It's a wave of probabilities, a wave that tells us the likelihood of finding the atom in a specific place or state. And here's where it gets even more mind-boggling. These waves don't just represent the many states an atom could be in, they are those states. Until a measurement is made, the atom exists in all those states simultaneously. When we observe or measure the atom, this wave of possibilities collapses into one reality. The atom then appears to us as a particle, but until that moment, it exists as a wave, a ghostly presence of all its potential states. This is the strange, counterintuitive, and absolutely fascinating world of quantum waves. This concept, as bizarre as it may seem, is a cornerstone of quantum physics. It's what allows quantum computers to perform complex calculations at blazing speeds and quantum teleportation to be more than just science fiction. In the quantum world, single atoms exist not only as particles but also as waves, a phenomenon that challenges our understanding of reality. This is the paradox and the beauty of quantum physics, where the seemingly impossible becomes the norm. So, what have we unraveled about the quantum world today? We've delved into the microscopic universe, where we discovered single atoms and their unique properties. We've seen these atoms transform, morphing into quantum waves in a startling display of physics at work. This is the quantum world, a place where the ordinary rules of physics are turned upside down. In the end, the quantum world remains a mystery. But one thing is certain. It's a universe of endless possibilities, where single atoms can morph into waves of probabilities.